Mr. Long here. I'm going to do a screencast today on how to determine rates and what's called initial value or constants. Oh, sorry folks, I thought I had paused that, but clearly I didn't hit pause. Anyway, so as I said, we're going to work on how to figure out rates and how to figure out what the constant or initial value is. Actually, this one, the initial value is showing already here, and it's not supposed to be. So you know what? Let me pretend that you haven't seen that. So we're just going to take that out right there. So let's forget what that number actually was. So here we go. So what is the scenario here in this situation? Well, this is all about piggy banks over a period of time with a constant or a constant rate of change. Okay, so the rate of change is constant. It's not changing. So there's the same amount of money is going in every deposit or every withdrawal. So the first thing you want to look at when you look at a table of values like this, and remember a table of values compares X and Y, and it looks at how they're related. So as you read this over, you've got some information here. So I think the first bit of information we probably need to look at is what do those pieces of information mean? Well, the first one means that at 8 weeks, there's $61 in the piggy bank. And at 13 weeks, there's $91 in the piggy bank. So from that, that's enough information actually, since we have a constant rate of change, to figure it out. And the way we always do that is we look at how things are changing. If we're trying to figure out rate of change, it only makes sense that we figure out the change. And remember, delta x means the change. Oh, whoops, that should say delta y. That means that we should do the change in y. So that's the change in money. So I'm going from $61 to $91. So that money is increasing. And 91 minus 61 is $30. So it increases by $30. Now, how many weeks? Is that in 1 week? Is that in 2 weeks? 10 weeks? Well, I go over to here and I do the difference in X. So that's the difference in weeks. So 13 minus 8 is 5. So that means it went up by 5 weeks. Okay, it went up by 5 weeks. So as I go through this, I know now, and I can go down here, I know that M, the rate, equals delta y divided by delta x, which in this case is I'm going up by $30 in 5 weeks. Okay, that's the change. Change in weeks, change in money. Rate of change. $30 divided by 5 weeks. Whoops, 5 deposits, I should say. And I know they have to be deposits because it's going up. So I should change that to deposits. And so that's 30 divided by 5, or 5 into 30. So it's $6 every single deposit, okay, if it's a constant rate of change. So I'll go back there. Remember, at any time when you're watching one of these videos, you pause it, rewind it, go back over things. So we know that the money is increasing by $30 every 5 weeks, which is the same as $6 every 1 week. So how do I figure out, after that I need to figure out how much money there was in the piggy bank at the very start. How big was that initial deposit that only occurred the once? Okay, how much was it? So what I do is I notice that at the start, of course, that's 0 weeks or 0 deposits or withdrawals, right? And that means the number of regular deposits or withdrawals, right? Because you have a certain amount of money you start with. So at the very start, there was a lump sum of money put in, a bunch of money put in the piggy bank. And I need to figure that out. Well, what I know is that from 0 to 8 weeks, that's an increase of 8, whoops, I shouldn't be saying weeks, 8 deposits. Of money. So there were 8 deposits, and I know we figured out that every deposit is worth $6. So 8 deposits, and they're $6 each. So how much money is that? $6 every deposit multiplied by 8 deposits, right? That's how much money the piggy bank had increased by over 8 weeks, or 8 deposits. I'll never get that right. So from 0 to 8 is 8 deposits were made. Each deposit was $6. So that works out to a total of $48 were deposited over those first 8 weeks. Well, if $48 were deposited in those first 8 weeks, and in the end I had $61, how much money did I have at the start? So I think about it this way. I started with an unknown amount of money at 0 weeks. I added $48 over the first 8 weeks, and I ended up with $61. So how much did I start with? So what number did I add to $48 to get $61? And I think if you do the math, you do 61 minus 48, and it's $13. I started with $13. So now I could check it actually and say, started with $13, I added $48 over the first 8 weeks, that's $6 a week, and I finished with 61, so that makes sense. 13 plus 48 is $61. Well, now I actually have enough information to write my equation, because I know that M was $6 per week, that's the rate, and B, which is the initial amount I put in the piggy bank, is $13. And we know our equations are of the form y equals mx plus b. But in this case, it's the piggy bank balance equals m multiplied by n, the number of deposits, plus b. So we have to remember what m and b mean. This b refers to balance. This b refers to the initial amount in the account. Right? So what does our equation look like? Well, the piggy bank balance is $6 per deposit, or 6N, starting with an initial amount of $13 in the piggy bank. Okay, $13 in the piggy bank. So I have to solve 2 problems now. I go back up to here, and what I want to figure out is, if there were 20 deposits, how much money would I have in the bank? Or if there's $205, how many deposits did I make? Okay, that's the sort of questions that we need to answer. So these last 2, I can use my equation quite easily. So let's see. Here are the two questions. The first one, I know that N was equal to 20. So there's 20 deposits. And I'll go back up and look at this. In the other one, there was $205, and we want to figure out how many deposits that took. So in this one, I want to figure out, if there's $205, how many deposits did it take to get there? Okay, those are the 2 questions. So remember, when we do these questions, we're supposed to write the formula, which actually I have right here. Then the next step is to substitute. So for the problem over here, I'm going to replace n with 20. So b equals 6 times by n plus 13. And n is 20. Okay, and I would just simply put that in the calculator. And the balance would be 6 times 20 is 120, plus 13 is $133 after 20 deposits. Okay, for the other one, where balance is $205, and I have to figure out the number of deposits it took to get there, I have to substitute this in the correct place. So that's mean I'm going to have $205 equals 6n plus 13. And again, pause, rewind, look things over, folks. But in this case, I have that substitution done. I've replaced B with $205, and now I need to do inverse and bedmass. And what I'm going to do, I think, is make this a little bit smaller down here, or give myself some more room. So I know I'm going to come down to here. So $205 equals 6n plus 13. And what I want to do now is use bedmass and inverse. So remember what I'd like you to do from now on: bedmass here, inverse here. And for bedmass, I look at the variable that's shown. In this case, I have n right there. So I start with n, and I notice the first thing that gets done to n is there's multiplication by 6. The next thing there is adding by 13. Now to inverse that, I have to reverse the order of those operations and actually reverse the operations. So it's, instead of multiply plus 13, I do the inverse, minus 13, then I divide by 6. Okay, and if I double check this, just see the operations, minusing 13, well, that will get rid of that plus 13, and dividing by 6 will get rid of that multiply by 6. And now I do it to the other side. So first thing I have is 205 minus 13. And so 205 minus 10 is 195. So 205 minus 13 is 192. And then that 192 has to be divided by 6. So what is that, folks? What is 192 divided by 6? And I'm going to let you do that yourself, actually. And that's going to give you a value of n equals, well, we know that 30 times 6 is 180, so that's 32 deposits. Okay, so I had to take that 192 and divide by 6. Okay, folks, so that's how you complete those tables when there's pieces are missing. The big idea there is you want to understand what rate means, what constant rate of change means, how to work backwards and get the initial value or the constant. In this case, it was the $13, and then after that, you just have to know how to use the equation to determine missing values. Have a great day.